A job it took over was moving about 400 gigabytes a month. After I rewrote it, the same job moved 9, same source, same pages, same rows in the same table at the end of the night. The old version opened a real browser for every URL. The new one asked the site directly for the data that browser was going to fetch anyway. That is a cost decision and almost nobody notices they are making one. Why I get to say that? I sell the addresses these jobs run through. SIM cards on Singapore carriers, modems on a shelf in my flat, about $10 a month per line in carrier data and another $50 in depreciation on the modem itself. Residential supply gets billed by the gigabyte. So a customer who renders every page is worth more to me than a customer who does not. I still tell people to render less because somebody who burns a package in 4 days does not buy a second one. I also run my own scrapers through my own lines. That is how I find out what a job actually costs before a customer has to tell me. A browser is a different class of client. When people say a site needs a browser, they usually mean the HTML that arrives has nothing in it. An empty container, a script tag, and the content shows up afterwards. So the fix looks obvious. Drive a real browser, let the page assemble itself, read the result off the screen. It works. It is also somewhere between 10 and 100 times more expensive than a plain request, depending which cost you are counting. Memory first. A plain request holds a socket and a buffer and whatever your parser needs for a moment, a few hundred kilobytes. A Chromium instance with one page open sits somewhere between 300 and 500 megabytes before that page has done anything interesting. Processor is the same story. Parsing the document, running the layout engine, then executing every script the page ships is real work. A modest box that would happily hold 400 plain connections in flight will manage 6 or 8 browser instances before it starts swapping. That cost is the one people notice because they can hear the fan. The one that ambushes them is bandwidth. The bytes you did not ask for, you wanted one document. What arrives is that document plus everything it references. Images, fonts, a couple of style sheets, an analytics script, a tag manager, a chat widget, a consent banner, and whatever advertising vendors that page happens to load this week. Open the network tab on an ordinary retail product page and count the requests. 80 to 140 is normal. One of them is the thing you came for. I measured one target properly last year because the invoice had stopped making sense. Fully rendered, a single product page cost 2.6 megabytes across the wire. The data behind that same page, fetched on its own, was 31 kilobytes. That is a factor of about 80 on a bill charged per gigabyte. 60,000 pages a night is a small job. Rendered, that is 156 gigabytes. Going straight at the data, it is under 2. People on unmetered data center addresses feel none of this. Then a target forces them onto residential or mobile, they keep the same rendering job, and the first invoice looks like a billing error. Look for the request the page makes. Here is the step to take before you reach for a browser at all. Open the page in your own browser with the network tab already up and reload it. Filter to fetch an HSR. What you are hunting for is the request the page makes to fetch its own content. A page that builds itself in the browser has to get that content from somewhere. The JavaScript did not invent it. It arrived over the network, in a structured form, from an address you can read off the screen. That source is usually smaller than the rendered page and better labeled. Smaller because it is data, without a page's worth of furniture wrapped around it. Better labeled because the fields have names. A price is called price. You stop writing selectors that break the week somebody renames a CSS class and it moves less often. That endpoint is what the site's own front end runs on. Redesigns shuffle the HTML constantly. They move the data source far less because moving it means rewriting their own app. Sometimes there is no separate request at all. A lot of frameworks dump the whole initial state into the HTML as a blob of JSON inside a script tag. View the source, search for a value you can see on the page, and if you find it sitting in a data structure, you are finished. One request, no browser, already parsed. When you cannot avoid a browser, there are two situations where none of that helps. The first is content that only exists after an interaction. A filter has to be set, a tab has to be clicked, something has to be scrolled before the next batch loads, and the request that fetches it carries a token the page only mints once it has run. The second is a challenge that has to execute. A site putting a JavaScript challenge in front of everything is asking for something a plain client will not produce, and going around it is a question about that site's terms rather than a technical puzzle. Read the terms and the robots file first. If the answer there is no, the answer is no, and I'm not going to walk you through it. There is an honest third case, time. If the endpoint sits behind a signing scheme and you have a deadline on Friday, running the browser is the cheaper decision this week. Just write down that you made it, because that one arrives on an invoice every month afterwards. Making the browser cheaper. If you are running one, run it thin. Block what you do not need. Every browser automation library lets you intercept requests and abort them by resource type. Kill images, fonts, media, and style sheets, and the page still contains every word of text you came for. That alone usually takes 70 to 80% off the transfer of a heavy page. It takes work off the processor too, because nothing has to decode a picture nobody is going to look at. Block third-party hosts as well. The analytics, the tag manager, the advertising, the session recorder. None of it has anything to do with your data, and all of it is on your bill. I keep a short list of host names that get aborted on every job, and it barely changes between targets. Then reuse the instance. Plenty of scrapers start a browser, load one URL, close it, and do that 100,000 times. Process startup is 1 to 2 seconds of pure overhead per page, and across a big job that is hours of nothing. Run one instance and open a fresh context per unit of work. Contexts are cheap, they carry their own cookies and storage, and you keep the isolation without paying for a cold start every time. One caution there. A single instance holding 40 tabs is a good way to run out of memory slowly and confusingly. Keep a handful of pages per instance, run a few instances, and restart them on a schedule, because they leak. Wait for the thing, not for the page. Most of the flakiness people blame on the target is really their waiting strategy. Waiting for the whole page to go quiet is the default everyone reaches for, and it is the worst option available. A page with a polar in it, or a chat widget holding a socket open, never goes quiet, so you wait for the timeout on every single page, forever. A fixed sleep fails differently. 2 seconds is too long on a fast day, and too short on the day the target is slow, which is the day you needed it to be right. Wait for the element you came for, the specific selector, or the specific response landing on the network. It returns the instant that thing exists, which on a good page is a few hundred milliseconds instead of 5 seconds of staring. 5 seconds a page against 800 milliseconds a page, over 100,000 pages, is the difference between a job that finishes overnight and a job that does not finish. The failures get honest too. If the element never appears, that is a real event worth logging, and it usually means the page told you something you were not reading. An empty result, a notice, a form you did not expect. The expensive client is not the safe one. There is a belief that driving a real browser makes you look more like a person, so it must be the safer option. Be careful with that. A browser does produce a browser's headers and the browser's handshake, and that removes an entire category of mismatch. That part is true. But an automated browser also puts far more surface on the table. It is a bigger, more detailed client, and everything it reports about itself can be checked against everything else it reports about itself. A plain client sending 8 headers gives a site 8 things to look at. A headless browser under automation gives it a rendering engine, a font list, a screen size, a time zones, a pile of hardware answers, and the timing of every request it fires. So the heavier client is a different shape, with more of it showing. Quitter is a separate question, and it does not come with a price. I am not going to tell you how to file any of that down. The point is narrower. Spending 10 times more to fetch a page does not buy you safety, so do not pick the expensive option for a reason it does not deliver. What I built the expensive way. I had a job on a marketplace source that I built as a browser fleet. 8 instances across 2 boxes, a queue in front, restart logic, health checks, the lot. It took me the better part of 2 weeks to get stable, and it ran for about 5 months. It cost roughly 190 gigabytes a month on residential addresses, and it needed a machine that did nothing else. Then one slow afternoon I had that site open in my own browser with the network tab up for a completely unrelated reason, And there it was. One request, returning every field I had been pricing out of the rendered page with the fields already named. No token, no signature, paging was a number in the query string. The rewrite took an afternoon. Bandwidth went to about 4 gigabytes a month. The box went back to doing other work. And the runtime dropped by a factor I was too embarrassed to put in the commit message. 5 months, and I never once opened the network tab. I had decided on day one that it was a JavaScript site, and that decision closed the question before I ever asked it. I open the network tab first on every new source now, before I write a line. It costs 4 minutes. What I cannot tell you whether your target has a usable source behind it. Plenty do not. Some sign every request, some tie it to a session the page mints. Some genuinely assemble the content in the client out of pieces that only make sense together. And finding one is not permission to hammer it. The terms and the robots file still apply, the rate limits still apply, and an endpoint being easy to call does not mean you get to call it 50 times a second. What I can tell you is that the cheap check comes first, and hardly anybody runs it. 4 minutes with the network tab open, against 6 weeks of building the expensive version and paying for it all year. The block list I actually load on every job, the waiting strategy that replaced my timeouts, and what a rendered page really costs once you weigh it are at proxyscraping.org. Subscribe for more on scraping with proxy.